Hello everyone. Have you ever wondered how robots in warehouses and factories move items autonomously? Today we are driving into the world of automation with a line following robot, yet a simple yet brilliant solution to reduce manual labor and improve efficiency. In this video, we will be exploring how this robot works, the components used, and how you can build one by yourself. Let's get started. In factories and warehouses, workers often spend hours moving items manually. This is tiring, time consuming, and prone to errors. What if we could automate this process? That's where the line following robot comes in. How might we automate object movement along a fixed path? The solution is to build a low cost autonomous robot that follows a predefined line. To solve this, we have used design thinking, empathize, workers face fatigue and repetitive tasks. Define, we need an autonomous, cost effective robot. Ideate, brainstormed like ideas, RFID, cameras, or IR sensor. The prototype, build a robot using IR sensors and Arduino and successfully followed the line. Out of this, IR based line following was chosen for simplicity and affordability. So components used Arduino Uno, it is a microcontroller used to control the functions, the IR module to direct the line, and L298 motor driver to drive the motors of the chassis, and the DC motors to run the chassis, and the chassis kit plus its wheels, and the jumper wires for connections of circuit. Next is the battery to supply the current to the circuit. Next, as you know, this is the Arduino Uno, and there are many digital pins, analog pins, as well as the power circuit. Next is the IR sensor module, which detects the line. The one is the IR transmitter and other is the IR receiver. Here we have the potentiometer to adjust the sensitivity and the distance. Here we have two LEDs, one is the power LED and one to indicate the signal LED. And there are three pins, one is the output, which is the signal pin, and the ground used to connect to the ground of Arduino Uno. Next is the VCC pin, it should be connected to 3.3 voltage. Next is our motor driver. We have here power connections. Here we need to give the 12 voltage from the battery. Next is the ground, and this is the output 5 voltage. Here we have two out 1 out 2 and out 3 out 4. Here we need to connect our motors depending upon our circuit connections, and here we have enable A and enable B. This is used for controlling the speed of the motors. These IN1, IN2, IN3, IN4 are the signal pins used to provide the signal to the L298 motor that which motor should be turned on. And these are the DC gear motors should be connected to your chassis, and these wires must be connected to your L298 motor driver. So let's see how it works. Here higher sensors detect the light reflection, white surfaces reflect IR, black absorbs it. Arduino Uno processes the sensor data and controls the motor. Next, L298 motor driver powers the wheel based Arduino's command. The robot decides its movement based on a sensor inputs. If both sensors on white, then move forward. If left sensor is on black, turn left. If right sensor on black, turn right. If both on black, next stop. So this is the working principle of our line following robot. let's see the code for this line following robot. So this is the simple code for the line following robot. Here we have connected 4 motors to the Arduino Uno. The IN1, this is the IN1, IN2, IN3 and IN4. Left and right is the IR sensors connected to Arduino Uno, which one is connected to 12 of Arduino Uno and 13 of Arduino Uno. Next we have taken two variables left and right and kept it as 0. Here we have written down 4 functions. One is the left, right, stop and forward function. In the void setup, we need to set up the components as input or output. Here we have connected 4 motors, so it is the output device. Next, we are wrote the IR sensor, which is the input device. Next, in the void loop, we need to write the functions. In left variable, we will read the left value, means left sensor value is read on left variable. So when the left sensor is 1 and right sensor is 0, it should turn left. This is the we have written a function left here. It will go when the left sensor is 1 and right sensor is 0, this function will be run. So in that function we have wrote motor 300 and other motors are 0. It will turn to the left and it will turn to the left. Likewise, we have written to other. If the right is 1 and left is 0, then it should turn right. In right, we have written motor 1 as 100 and other as 0. Means motor 1 will be rotating and other 3 motors will be non-rotating. Likewise, if the right is 0 and left is also 0, we should stop the motors. Next, like forward, in the forward, if right one and left is also 1, then we should move forward in the same line. This is the code for our line following robot. Let's dive into the connections and check the output once.
So hello everyone. Today we will be doing the assembly of a 4 kit chassis. In this you can get all the accessories like screws, nuts, motor holders, and all the other accessories. Here are the motor holders. So let's start with the connection of the motor holders. So first of all, here you can see there will be a line. In this, the holder should be added like this. So rotate this and put the motor the way in which there is a hole in the holder of the motor. So here also you can see the hole in the motor. So let's match it and take the other holder and put it like this, like this, as you can see, and take the lengthy screw and put the screw in that. After putting the screw, take a nut and put it on the screw so it gets fixed tightly. Take another screw and put it on the lower hole and nut. Yeah. After this, the black one is an one side of the, you can place it in the one side of the motor. Another side you can put the wheel. So this is the assembly of the motor. So let's connect all the four side of the chassis. As the motor assembly is done, let's put the other plate at the top of the chassis. Here you can see there is a spacer wire. Just put the corner side of the chassis and put the screw by down. You can place the screw here and then you can simply put it and rotate it. So you can place it tightly. Do it for these four corners. So after placing the spacer at the plate, so let's put the second plate on the top of it and match the holes and put the screw. So finally, this is the complete assembly of the four-wheel chassis. Here it looks like this. So you can assemble it and get ready for the next experiment, which will be the line following chassis. Thank you. So let's start with the connection of the line following robot. So the the wires that is connected to the motors should be passed through the holes or the gap between the plate. So take these two motors of the wires upside and this also. So after taking the wires at the top, so place the motor holder. This is the L298 and motor driver, in which you can see is the IN1, IN2, IN3, IN4 for motor directions, and this is the outputs out 1, out 2, out 3, out 4, which is be connected to the four motors, one first motor, second, third, and fourth. So place the like two of these positive means the red up to these wires will be connected to the out one. Just loose the screw terminal, and place these two wires in out one, and tight the screw. So same like take all the flex and the output. So in this motor driver there will be a IN1, IN2, IN3, IN4, which will be connected to the Arduino Uno for the direction, whether to go right, left. To understand the direction to the motors, we use L29810 motor drivers with the pins of IN1, IN2, IN3, IN4. IN1, IN2 will be responsible for these motors, and IN3, IN4 will be responsible for the direction of these motors. So let's start the connection. Here IN1 IN1 will be connected to the pin 9 of the Arduino Uno, and IN2 will be connected to the pin 6 of the Arduino Uno. IN3 IN3 will be connected to the pin 3 of the Arduino Uno, and last IN4 will be connected to the pin 5 of the Arduino Uno. As the connection is done, so as we didn't give any supply to this motor driver, so let's give the power to the motor driver. To power the motor driver, we have given a 12-volt battery, in which there is a two male and female, and also a DC jack to connect with the to the battery. So first of all, below the motor driver you can see there will be a 5-volt ground and 12-volt screw terminals. So sort the ground of the Arduino Uno and the DC jack and give to the ground, which will be the middle one. First close it and place this which is connected to the ground of the motor driver to the ground of the Arduino Uno, and positive and this positive will be connected to the 12 volt. So let's connect this 12 volt to the motor driver, which powers on through the 12 volt. First close this terminal and tight it. As 12 volt power supply is given to the motor driver through this, like through this too, so we can connect through this, and the last one which is will be the 5 volt will be connected to the V in of the motor driver. So the power supply will be comes from the motor driver to turn on the Arduino Uno after dumping the program. Lose this screw and place the male jumper wire inside it and tight it. And connect to the pin 5 volt to the pin. And as this is the line following robot, so we will be needing two IR sensors. So let's connect the IR sensor to the Arduino Uno. So this DC jack will be used to connect with the 12 volt battery. So let's start with the connection of the IR sensor. The IR sensor works on the voltage of 3.3 volt, and you can see in the Arduino Uno there will be only one 3.3 volt. So take the breadboard, and take a common 3.3 and ground in the breadboard. Onto the positive and ground. So let's connect the IR sensor to the Arduino Uno. So right IR sensor means this. Let's connect it to the Arduino Uno. So in the IR sensors, there will be a three pin, which will be out, ground, and VCC. The VCC of the IR sensor will be connected to the 3.3 volt and ground to the ground, and out will be connected to the 12th pin of the Arduino Uno. 12 pin of the Arduino Uno. Like this, make the connection for the left IR sensor. Same connection like VCC to 3.3, ground to ground, and out will be connected to the pin 13 of the pin 13 of the yeah. As the connection is done, to place as it is line for line, so it detects the darkness or light black lines, so it should be placed like this at the downwards. The transmitter and the receiver of the IR sensor should be placed downwards. So to put this, we can simply use double side tape. I'm placing like this, and the same for the yeah. So this will be the complete connection of the line following robot. So as you can see, when you power the battery, the both motor driver and the Arduino gets on. As you can see this. First dump the program. First dump the program, and after dumping the program, remove the cable and remove the cable of the Arduino Uno, and then connect the 12-volt battery. Thank you. After connection, you can also plate the top of the plate, so it can look neatly like this, and you can put the screws in it.